Hello and welcome to This Explainer. Okay, let's dive into this, because today we're going to unravel a highly relatable mystery. You know the drill, right? For decades, people have turned to a late-night drink to just wind down. You pour a glass of wine, maybe a little whiskey, and boom, you are knocked out. It feels like the ultimate super easy sleep aid. But here's the paradox. Why is it that the exact same pre-bedtime drink that puts you to sleep so perfectly completely shatters your rest by like 3 a.m.? Well, today we're going to look at the fascinating, kind of hidden neuroscience behind what we are calling the nightcap paradox. Here is our roadmap for the day. First, we'll define this nightcap paradox. Then look at how we actually sleep, uncover what's known as the adenosine hijack, and then explore the withdrawal crash along with the hidden cost of binge drinking. Finally, we'll wrap things up with a healthier sleep solution.
Section 1. The Nightcap Paradox. Alcohol and Sleep.
So you've likely experienced this firsthand. Acutely, alcohol is an incredibly potent somnogen, meaning it significantly reduces the time it takes you to fall asleep. But that brings us to our central mystery for today. If alcohol makes us so sleepy, why does it ultimately ruin our rest? It's wild, right? You fall asleep effortlessly, but then fast forward a few hours and you're tossing and turning, wide awake at 3 a.m., feeling completely restless and overheated. Your whole sleep architecture later in the night literally just falls apart.
And listen, this isn't just a minor personal annoyance you can just shrug off over a morning cup of coffee. This is a massive systemic issue. Data actually shows that in the United States alone, the societal cost of alcohol-related sleep disorders exceeds a staggering $18 billion. $18 billion! Between profound insomnia, excessive daytime sleepiness, and the massive healthcare cost of relapse in clinical alcoholics, this biological paradox has a tremendous socioeconomic impact on all of us.
Section 2. How we actually sleep. Biology of sleep.
To really understand how alcohol breaks our sleep, we first need to look at how natural rest actually functions. Think of your brain's need for sleep kind of like a battery. This is called sleep homeostasis. As you just go about your day, your wake-promoting systems use energy, actively burning through ATP. Now, the biological byproduct of burning that energy is a chemical called adenosine. The longer you're awake, the more adenosine builds up in your brain, creating this physical sleep pressure. Once you finally drift off to sleep, all that adenosine clears out, the pressure dissipates, and you effectively recharge your battery for the next day.
Now, what's really interesting about this slide is how it illustrates that natural sleep is this delicate, really beautiful balancing act. It's essentially a biological tug-of-war between two main processes. Process C is your circadian alerting process. That's your internal body clock that tells you it's daytime and keeps you awake. On the other side, Process S is that homeostatic sleep drive we just talked about, the adenosine sleep pressure. During the day, Process C keeps you alert even as Process S slowly builds up. Then, at night, Process C dips, which allows the heavy weight of Process S to totally take over and pull you into a deep sleep.
Section 3. The adenosine hijack. Breaking the balance.
So what exactly happens when we introduce a nightcap into this incredibly delicate balancing act? Basically, a biological heist takes place. Alcohol doesn't just passively make you relaxed. It actively hacks this entire system through a crazy chain reaction. First, alcohol inhibits the reuptake of adenosine. Because it's suddenly not being cleared away, you get this unnatural massive spike in extracellular adenosine floating around in the brain. This sudden flood of adenosine directly binds to your A1 receptors and forcibly inhibits the wake-promoting neurons, your brain's waking centers, in a region called the basal forebrain. Essentially, alcohol artificially maxes out your Process S, sleep pressure, to literally shut down your brain's waking centers.
But right here is where the rug is completely pulled out from under you. Check out this timeline. During hour 1, you fall asleep fast. Through hours 2 to 4, you're actually getting highly consolidated deep NREM sleep, what we call delta power. Sounds great, right? But because this intense sleep pressure was artificially manufactured by alcohol blocking that reuptake, well, as your body processes the alcohol, the chemical hijack wears off, and suddenly, your natural homeostasis is in total chaos. From hours 4 to 8, your body experiences a severe rebound. Your sleep becomes completely fragmented, and you're just left staring at the ceiling.
Section 4. The withdrawal crash, chronic alcohol use. To really study what happens with chronic use, researchers use something called the Majorowicz rodent protocol, which closely mimics heavy human alcohol dependency. So the crucial point is what happens at a cellular level here. Over time, the brain tries to adapt to this constant flood of adenosine by actually downregulating its ENT1 and adenosine A1 receptor genes. Essentially, it removes its own microscopic doorways to block the chemical flood. So when the alcohol is finally removed during withdrawal, the brain's natural process S, that absolutely crucial homeostatic response, is completely impaired. Even if the subject is heavily sleep-deprived, the brain just can't register the sleep pressure anymore. The result? Profound, protracted insomnia that can actually last for years in human alcoholics, which obviously significantly increases the risk of a relapse.
Section 5. Binge drinking's hidden cost. The hidden damage.
To understand these highly prevalent human behaviors, researchers use the drinking in the dark or DID paradigm in mice, which perfectly mirrors human binge drinking patterns. And this brilliantly illustrates the lingering damage, which is just staggering. If we look at the recovery sleep after the initial intoxication wears off, the control group, who only had water, takes about 10 minutes to fall asleep when they're tired. But the alcohol group, their sleep onset latency shoots up to a massive 112 minutes. After binging, the brain's homeostatic system is just so scrambled that it takes nearly 2 full hours just to initiate recovery sleep.
Furthermore, not only does it take forever to actually fall asleep, but the quality of that sleep absolutely plummets. Look at this comparison. The percentage of restorative, deep NREM sleep in the control group is nearly 31%. In the binge alcohol group, it drops all the way down to 19.3%. Because the biological process S is totally broken by the alcohol, the body literally cannot generate the high-quality delta wave sleep it desperately needs to recover.
Section 6. A healthier sleep solution, natural rest. Let's move to and see how this builds into a much better approach.
Now that we deeply understand the cellular damage alcohol inflicts, we need a scientifically sound alternative, right? The absolute gold standard here is cognitive behavioral therapy for insomnia, or CBTI. This is a structured, proven 7-step guide that actively trains your brain to sleep naturally. Instead of relying on a chemical somnogen like alcohol that violently hijacks your adenosine system, CBTI uses behavioral conditioning, sleep restriction, and stimulus control to naturally realign your process C circadian clock with your process S homeostatic drive. It's amazing because it actually heals the system from the outside in.
Ultimately, the goal of this explainer is to help you build realistic, much healthier expectations about sleep without ever needing to rely on that chemical nightcap. We really have to respect our brain's delicate homeostasis, which leaves us with a critical question to ponder as we wrap up today. If a seemingly harmless drink before bed is secretly dismantling your brain's fundamental sleep architecture, what other quick fixes in our daily routines might be quietly sabotaging our body's natural balance?